I will start here with Troy since he is here on time, and we'll jump in with the introduction. So, Troy began his career with soils and compost at the Rodale Institute in Kutztown, Pennsylvania, serving as Rodale's compost specialist. Troy worked side by side with Dr. Elaine Ingham, who's also been on this panel in the past, performing experiments on large and small scale agricultural production. He went on to start and co-manage an organic farm, as well as serving as compost specialist for a large windrow composting facility. Troy is currently the owner of Living Roots Compost Tea, consulting with growers and composters worldwide. He's also the host of What's Brewing, a compost podcast. So he is well versed in all of these topics. So with that said, Troy, why don't you start by giving us a little overview of the work that you do as an entrepreneur in composting. What is that business like, and how did you get into it?
Hey, so I had originally gotten into this all through going back to school and took a 28-day class with Elaine, who at the time I didn't know who she was. This is back in 2010, 2011. And through that class, had an aha moment, knew that's exactly what I wanted to pursue. I went to apprentice with her on the microscope because I wanted to specifically work with her on apprenticing. I had no really prior experience with the microscope. So I went to Rodale to do that, and they liked me a lot and liked my work ethic and brought me on through a compost grant to work alongside her. And I just kind of went nuts from there. Really delving into it and working. I was in Pennsylvania and I moved back to Tennessee, and I just recently relocated. So while I was in Nashville, I started my own business. The Living Roots business, I'd like to change names. I originally started off on a suggestion of doing compost tea sprays locally. So that's what I started out doing, is compost tea sprays for landscapes, lawns, gardens, and farms. Basically as an alternative to chemicals for people to use. Not that I'm really into lawns, but if people are going to be spraying lawns or landscapes, I'd rather them be using compost tea or something natural and organic than chemicals. So I started off doing that, and then immediately my business morphed into a lot of consulting. So at this point, half of my business has been compost tea sprays, and half of it's been consulting with now people around the world who want to consult on compost making, compost tea brewing, microscopy, soil food web knowledge, anything like that that has to do with soil food web, compost, or soils. And then now I'm kind of morphing my business because I'm in the Northeast now. I just relocated back to Pennsylvania near Kutztown, so I'm back near Rodale. And I don't really know what's going to happen. I think I might start putting out more products. I'd kind of like to change my name. I feel like the compost tea name kind of puts me in a very small closet, and not as many people may pay attention to what's going on with what I'm doing because of that. And I do a whole lot more than compost tea, especially, compost. Compost is the basis of compost tea. So I really specialize in that and soil microbiology.
Fantastic. Well, look, so there is such a wide definition of compost out there, and I think this is where people get confused. And we've identified this as one of the key points that farmers are working to get better at because of how important it can be for kickstarting soil health. But because there are so many different types out there, everything from hot composting methods, cold composting, and even vermicompost and bokashi, which is more of a fermentation, all get lumped into these, as well as a misunderstanding of whether or not this works as fertilizer or whether it's inoculant for microbiology into the soil that releases the nutrients and the minerals that are already in there. Can you give us an overview about these different types that I've mentioned and what some of the key importances are or differences are between them?
Yeah, so I usually refer to compost as an inoculant or inoculum, where you're going to be inoculating your soil with the biology that's contained within compost. Most people think that compost or compost tea is full of nutrients and that's what works for the plants, which is true in a way, but it's because of the microorganisms making those nutrients available. So the most nutrients in the world in soil is held in microorganisms. It's a matter of cycling those nutrients and working with nature and working with those microorganisms to get the nutrients that are contained within those microorganisms to plants, and plants have a symbiotic relationship with these microorganisms, with bacteria and fungi, where the plants can manage their own needs. It's just a matter of getting the biology correct in the soil. So in different types of composting, you had mentioned, we got vermicomposting, thermophilic composting, static composting, bokashi, which I'm not necessarily a fan of, black soldier fly composting, anaerobic digestion. There's a lot of different things, but the key point is that microorganisms are breaking down organic matter and making these nutrients available to plants. And it's the whole kind of circle of life that happens within nature or a forest system or something like that. So with these different types of composts, you're going to have varying degrees of quality. I focus more on aerobic composting and aerobic compost, aerobic microorganisms. So with other types of anaerobic composting, you're going to have anaerobic microorganisms that are breaking down or taking over the material. But then in the end, you still have to allow that stuff to age or cure and allow the aerobic or aerobes to come and take over and finish the compost. With what I'm doing or what I'm trying to teach folks through farms or on their own home use is to try and get compost. It depends on your situation, but for most people, they're trying to get compost as quickly as they can. And I'm wanting them to get as much biology as they can through that compost. So what I'm teaching people, or the ones that I focus on, are going to be focusing on managing according to the biology in the compost or in that organic matter, and then trying to enhance that biology to bring about more populations and break it down even more.
So along those lines and what you're trying to achieve, even though there are a wide range of techniques and materials that you can use to achieve that, how do you go about assessing the health of a compost pile and assuring that it has the microbial and fungal populations that you're looking for to get the results that you can really work with and apply into your own soil? How do you analyze that through the process?
Well, I'm using a microscope throughout, so I'm able to take a sample and look to see, do I have a diversity of bacteria? Do I have any fungi in there? What about protozoa, like different amoeba, flagellates? What am I working with? If you don't have access to a microscope, you're going to kind of have to basically go off of what you're seeing and smelling. So if you're seeing a good amount of breakdown, let's say you're not seeing a good amount of breakdown. Let's say you're seeing a compost that's full of woody tissue and wood chips. Either it hasn't been fully composted, or there's not a lot of microorganisms that are in there, that you're having a lot of chunks of wood chips or maybe even other material that's just not getting broken down because you don't have the biology there to break it down, or for some reason the way you've managed the pile, there's not enough water or moisture to help the biology, or you've allowed it to get really super hot or go anaerobic to where other types of microorganisms have taken over, and you're not getting a lot of good breakdown. So if you're not using a microscope, the best way to judge is, over 2 months, 4 months, 6 months, are you getting a continuous breakdown, a nice breakdown of material, or is it kind of look about the same as it did at 2 months, at 4 months, and 6 months? The ways to make sure that you're keeping the biology going is you want to make sure that you're getting air in there somehow, every so often at least, and you want to make sure that you're keeping your pile moist but not too wet. So the consistency of a wrung out sponge is the way that most people like to describe it, or 50% moisture. These microorganisms that we're working with need moisture in order to function and thrive and survive and go on reproducing. So you need to provide them with the moisture. You need to make sure that your material is staying moist. But just like if you have some moisture, if you water your lawn for 10 minutes, it's gonna help it. But if you flood your lawn to where it's just sitting in water, that's not going to be beneficial at all. Same with compost, you want some water, but if you're flooding it to where you've just got too much water and causing it to go anaerobic, that's not going to be good. But I always like to use a food. Humans preserve food through a few different ways. We use salt, or we use like bags, or airtight containers, and we dehydrate food. So the reason that we dehydrate food, like you put fruit in a dehydrator or produce in a dehydrator, you're taking away the moisture because you're not wanting any microorganisms or mold or bacteria to come in onto the surfaces of your banana or your mango and to break it down. You want to dry it out so that microorganisms aren't able to really live on the surface there. So also, we dehydrate food, we put stuff in an airtight container because we don't want that air to get in there. In the opposite effect, we want to enhance these microorganisms in compost. So we need air, we need moisture. We're trying to get things to break down, unlike leaving your sandwich out or your loaf of bread out on the counter, or putting it away as opposed to leaving it on the counter. I mean, because if you leave it out on the counter, your bread's going to get moldy or your sandwich is going to get moldy. We want to enhance those microorganisms that are going to break down this organic matter in compost. So the best method that you can come about to compost to achieve that is what you're going to go for. And in my experience, vermicompost is a great way to provide biology and break things down, or thermophilic composting. Different ways of thermophilic composting is a great way too. It's all in how you manage the pile though.
Now you're talking a lot about getting air into the pile, anaerobically decomposing the organic matter that you're using. But there are some people who also advocate for anaerobic. I had it the other way around. It's aerobic if it's got oxygen in it, and it's anaerobic if it doesn't, right? And so anaerobic decomposition also has the potential for some benefits. I've heard it advocated by certain sources, and can break down and make bioavailable some difficult minerals that otherwise aren't water soluble. Is there a use for anaerobic compost, or are the negative aspects of it sort of too dangerous or kind of outweigh the benefits?
Yeah, it has its place. There are gigantic anaerobic digesters that people are able to turn a lot of food scraps into. I wouldn't call it compost. I would call it a compostable material. So you're breaking it down with these anaerobes, but then that's what I was saying. You have to put it through a curing process where it's going to age, and you allow air into it after that anaerobic process. So yeah, it has its place. Trying to break down a lot of food scraps, it may be easier, because due to space in a city or something like that, it may be easier to put it through an anaerobic digester. Or if you're like worm composting, people on a large scale with doing large scale worm composting will do what's called pre-composting, where they're putting something through a thermophilic phase before they feed it to worms in order to break or to kill pathogens and weed seeds. So using an anaerobic, if you say you don't have a lot of real estate that you can be making thermophilic windrows or piles or something like that, but you do have a small basement space or something in a warehouse or something like that, you could have a anaerobic digester where you're putting it through the anaerobic digester to put it through the thermophilic process and then take that and feed it to worms. So it has its place. Everything has its place. It's just my preference to do other type of composting. Yeah. I don't look down on those things, or it's not like I think that they're bad. Everything has its place. It's just a matter of your environment and what you have to work with.
And so getting rid of pathogens and especially killing weed seeds is one of the benefits of thermophilic compost, getting it up to heat so that those organisms can't thrive and that those seeds can't germinate. Are there any other ways of eliminating those risks without having to bring it up to temperature? Or is that only achieved by reaching a minimal temperature?
Worms can also help to break down pathogens. If the other lady was here, she might not be able to answer this question better. I know she's worked a lot with microbes. I know from my experience and what I've learned that if you were to not have necessarily put something through the thermophilic phase, but feed it to worms, as long as worms work most of that material, they're going to be breaking down pathogens. And over time, if you have, like a static compost pile, if you're just like a backyard gardener who's throwing stuff into a heap, you throw some grass in there, you throw some food scraps in there, you may have some pathogens at first, but over time, as it ages and goes more aerobic, if you're able to turn it and work with it and manage it, over a year's time, it should be that you're getting rid of those. As long as you're keeping it aerobic and not too wet, you should be getting rid of those pathogens.
All right, so let's go through other types of composting, starting with the fungal or the bacterial dominant types. There seems to be a lot of hype right now around fungal dominant compost and the advantages that they have for creating a forest floor-like environment in which a lot of different plants can thrive, essentially. First of all, I've also heard that it's not possible to create fungal dominance in compost, that's something of a myth, that it can have more fungal life, but it's unlikely to ever be dominant in comparison to the bacterial life. And second of all, are there real benefits to doing it this way, or is it just something new that we're starting to discover as we learn more about mycology?
So according to research that's been done in the past 10 to 20 years, it is beneficial to get more fungi going into your soils. So over the past 10 years that I've been doing this, since I worked with Elaine, my entire goal has been get more and more fungal compost, or get compost that's more and more fungal, more fungi in it, or fungal dominant. It can be extremely difficult. It depends on your starting materials, from my experience. So I consulted with a guy who was getting a lot of material from large old forests in California. He somehow was able to get wood chips that they were cutting down, like these super old trees in a national forest. And he was composting that with palm leaves and then feeding it to worms. So these huge old trees were full of fungi, because fungi is not just in the soil, but it's within tree, the architecture of the tree or the body of the tree. And sorry, there's like a wasp or something. And on the surfaces of the outside, so on the foliage. So he's getting this material that's already full of fungi, composting it and feeding it to worms. So he's got a very fungal dominant material to start with. And so when you look at his stuff under the microscope, it's definitely fungal dominant. Dr. David Johnson, who he and his partner or wife do the Johnson Sioux bioreactor, I think is what they call it. They have a certain method of composting, and he's shown that he can get fungal dominance through making compost this way. You can find a video on YouTube if you want to look it up after this session. But he's found that you can apply this compost that he's made that is become fungal dominant at a rate of 1 ton per acre, which is barely anything. If you can think of 1 ton, or like basically a couple cubic yards of compost onto 1 acre. And he's been able to change the biology in the soil and advance it in succession to where he's getting more fungi. And he's using, again, so that you would be considering that compost an inoculant. You're inoculating the soil with compost in order to get these microorganisms into the soil. So Yeah, and then you had Elaine on. I don't know how much she talked about succession, but in plant succession, if you were to go out and disturb soil through tilling or just taking away the vegetation on something, you would be making that soil bacterial dominant. And then as you're going to start out with some pioneer weeds that come up there. And then if you continue to let vegetation grow and not disrupt it, you're going to move through succession from pioneer weeds to grasses to shrubs to trees to forests. And as you're moving through succession, you're going from bacterial dominant soils to equal ratio of bacteria to fungi to forest systems which are going to be fungal dominant. So what people are trying to achieve through this method is to get more fungi in the soil to a place where the biology is correct as to the kind of crops that you're growing. Did that answer your question fully?
Yeah, that's a really good start. Well, let's go a little deeper into that now. There's the idea that certain types of compost might be better for certain types of crops or for certain types of growing methods. Since you've worked with growers in many different places, have you found that there is any noticeable difference in the type of composting method used for things like market gardens or for tree planting efforts or for broad scale applications that are significantly better than others?
I'm trying to clarify that I have your question correct. You're asking that are there certain types of composting, like is thermophilic windrow composting better at producing compost for a certain type of crop than like vermicompost? Is that what you're trying to ask?
Yes, exactly. If there's tailored types of composting that are better or worse for certain types of growing or certain types of crops.
I wouldn't necessarily say it's the type of composting as much as the quality, but you're going to have certain types of methods or ways of management that are going to produce better biology in your compost. So the Johnson Sioux bioreactor, they've come up with a way that they're able to really enhance the biology and get a lot more fungi going. Or I found I really wasn't a fan of aerated static piles at first. And then when I was able to control the feedstocks on my own and practice it on my own scale and at home, I was getting extremely good biology. And like I said, vermicompost is normally gonna give you really good biology. So most vermicompost is gonna be more bacterial dominant than fungal dominant. So this is kind of a weird situation too, though, because people have found that vermicompost is great for grapes, and grapes should have more fungi in the soil or equal amount fungal to bacterial ratio. But people have a great success with using vermicompost on different vineyards. But yeah, I don't know. That could be like a long drawn out answer as far as like what you're trying to get to. But yeah, really, it's the management of any of the types of composting that you're doing. It's the management of it, of paying attention to biology or knowing when to like add air or turn a pile or things like that in order to focus on good biology and beneficial biology. But yeah, so like from the experience and research that's been done, like the Johnson Sioux bioreactor, that type of fungal dominant compost should be better for, you know, more tree crops, or most any soil is going to be lacking fungi. So anytime you can get compost that's more fungal dominant you're trying to balance out a soil. So you're trying to add fungi to the soil. So most any soil is going to need more fungi, basically, no matter what crop you're doing, as long as it's not, you know, just like lettuce or some early succession crop. I hope that makes sense.
Yeah, for sure. And that makes me wonder what your experience and relationship with using bokashi is, because it's kind of an outlier in the composting world. It often gets lumped in with composting methods, but technically it's a type of fermentation that is often used more as a fertilizer rather than a bacterial rich compost as we normally think about it. Would you include that in the list of composting methods, or does it really stand alone as a separate type of soil improvement and fertilizer?
I would consider it part of a composting method. So I know people take bokashi and put it directly onto plants and have some results. What I'm trying to do through making compost is get a diversity of microorganisms. So by using a diversity of materials as feedstocks and starting materials, a piece of hay, certain type of hay is going to have certain bacteria and protozoa on it, where wood chips and things like that are going to have other types of bacteria and fungi on it. So you put those together and you're going to get more diversity. With bokashi, I went to the NC State Vermiculture Conference in 2019, and there was a guy there named Dr. Zach something, from the Rocky Mountain Soil Institute is what I think he calls it. He has a DNA sequencer, and he had done DNA sequencing on compost tea, vermicompost, bokashi, and like one other thing. And so like compost tea, he did DNA sequencing, and it was just like tons of different DNA, just all kinds of, like a super big diversity of microorganisms. With bokashi, it was 99% bacillus. So you're pretty much getting all of the same type of bacteria in a bokashi, whereas I'm trying to get, like I said, I'm trying to get a diversity of species. So if you use, if you're an apartment dweller who chooses not to have like an indoor worm bin, or you want to do bokashi, it can be a good way to break down food scraps before, like feeding. You could do bokashi and then put that into an outdoor compost pile, or do bokashi and then feed that to worms. I would consider it like another type of kind of pre-composting, or breaking stuff down in order to get it ready for composting that's going to make it healthy, full of healthy aerobic microorganisms.
Well, so we were talking a second ago about the feed materials for compost and how that can contribute to the diversity of microorganisms and fungi that are in there. Let's go over some of the common feed and materials that are used for composting and what they can help to promote, and some that are either overrated or downright incorrect or often troublesome in composting piles. Maybe starting with your carbon sources and dividing them between the carbon and the nitrogen sources.
Yeah. So carbon sources, you have browns and you have greens. I think most people are familiar with both of these terms. The greens are going to be more nitrogenous materials, where the browns are going to be more carbonaceous materials. So brown or carbon material is going to be wood chips, stalks, sticks, paper, cardboard, sawdust, anything that's woody, got a lot of carbon, lignin, something that's going to be harder to break down. That's going to be a carbon source, whereas green material is going to be anything that's easier to break down, or anything that's cut green, or even food scraps. So grass, green leaves, not dead leaves in the fall or autumn, but green leaves, weeds. So straw and hay are the exact same plant. Hay is cut when it's green, straw is cut when it's brown, but it's the exact same plant. So if you cut it green and it's hay, that would be considered a green source. Whereas you cut it brown and all the proteins, sugars, and carbohydrates have seeped into the roots for the season, that's going to be considered a brown source. So straw, brown, hay, green. We were kind of talking about succession before, and bacteria and fungi. So green material is going to be more of a bacterial food, and brown or carbonaceous material is going to be more of a fungal food. So if you're trying to get more fungi into a pile, you'd want to have, over 50% or majority brown material. There is a point where you can get, too much brown material. I would say the threshold that I've experienced is somewhere around, 75 or 80% brown to the rest green, either nitrogen or high nitrogen. You can also have too much nitrogen. So I was working with one farm and they couldn't get their piles to heat up, and I was suggesting they had some odd starting materials, and I couldn't really figure out what their issue was, and they ended up sending in a chemical analysis, and they realized they had too much nitrogen. So they actually had to get more carbon into the compost to get it to heat up. And generally, when you're trying to do thermophilic compost and not getting temperatures, or you're not getting the thermophilic temperatures that you want, you generally want to add more nitrogen or a high nitrogen source, which would be manure or a leguminous plant or alfalfa. Was there any other part of that question I didn't answer?
No, those are a really good start, and those are the common ones that people are often working with. Let's talk a little bit about wood sources, wood chips specifically, and the difference between coniferous trees and deciduous trees. That kind of wood can make a difference. How big or small the pieces are can determine how quickly it breaks down, and also the types of microbial life or fungal life that it promotes, as well as, so we're just kind of generally talking about wood sources here, but also the concern that it can absorb or extract nutrients from the soil if it's not properly broken down. Can you kind of just talk about that as a material and how it fits into healthy, sort of robust and diverse compost?
Yeah. First, you mentioned like the particle size. So I generally tell people to stick with material that's like if you're going to go with wood chips, something that's 2 to 3 inches or smaller, nothing too bigger than that, because we do need some fluff in a compost pile, something that's going to be porous and allow for air movement throughout the pile. While we're on the subject, I'm going to mention sawdust. A little bit of sawdust is good. What's really weird about sawdust is it has an extremely high carbon to nitrogen ratio. So you would think that sawdust, it's like more broken down, it'd be easier to break down, but because it has once you turn it into sawdust, it creates such a high carbon to nitrogen ratio, it's actually harder, it takes longer to break down. Plus, I just talked about the breathability, and if you've got a lot of small material, like some coffee grounds are good, but you wouldn't want to load a pile down with something like coffee grounds or sawdust, because like you buy a bag of flour, think of how much air is going to flow through that material because it's such small particle size. So you want chunky stuff, you want fluff, you want a variety and diversity of material sizes to begin with as well. So from tiny to 2 to 3 inches is about what I stick with. And if you're throwing sticks and stalks in there that are longer, if you're turning this stuff by hand, it can be really difficult to hit some pieces of material that are 2 feet long, and then it's catching all this other material and you're having to lift 50 pounds at once. That can be really difficult when you're doing it by hand.
Yeah, that was a mistake I made in my early days.
Yeah. It sticks in your pitchfork and makes it such a hassle. So as far as the putting wood chips into, I think that it's been talked about a lot now that you don't want to be putting wood chips directly into soil or mixing wood chips into soil. And most people are worried about it robbing the soil of nitrogen, and you're trying to put fresh plants in there that need this nitrogen. People have had luck by putting in wood chips or adding wood chips to certain things, but then also adding a bone or blood meal so that they're adding a high nitrogen source to make up for the nitrogen that's taken up. So I don't have a chemistry background. Again, this might be a better question for the lady who was going to be here. My understanding would be that even though wood chips are more of a fungal food, you're going to be having bacteria that's coming in to, you've got a lot of sap and sugary stuff that are going to be on the wood chips. So right at first, for the first month or so, you're going to be having bacteria that are going to be grabbing onto those wood chips and eating away at the sugars and the saps and things like that. I believe that that's why, because this bacteria is going to be where your source of nitrogen, like I said in the beginning of our conversation, the nutrients are held within these microorganisms. Charles is here now, I see. The nutrients are going to be held within these microorganisms. So if you've got all this bacteria that's migrating to the wood chips to break down these sugar sources and saps and things like that, then they're going to be taking away from nitrogen that you might have for plants. So that's my understanding of that. I think I answered all the parts of your question there.
Yeah, that was a really good breakdown. I really appreciate it. And let me just introduce Charles since he got here, and thanks for holding down the fort until now, Troy. Hey, Charles, how's it going? I'm really glad you're able to make it. Have we got you there? You may be on mute. Oh, I think we got you now. I hope he can hear us.
If you want, I could field another question until he gets online here.
Well, let me quickly give his introduction because I have a feeling he'll be available in just a second. So for anybody who doesn't know Charles Dowding, since 1982, Charles has created and cropped 4 no-dig market gardens on different soils, from stone to silt to clay. And in the 1980s, he cropped 7.5 acres, which is 3 hectares, of no-dig beds. Currently, he grows vegetables on 1/3 of an acre in Somerset in southwest England, which is zone 8 on your frost zones. And he also sells 20,000 pounds, pounds being the British currency, not the weight unit, of harvest locally, mainly in salad leaves, and many vegetables are served on the courses at Home Acres, his farm. Charles' methods are easy to understand and work on small areas as well as large ones. He has written 10 books and an annual calendar of sowing dates. He runs a YouTube channel and writes for national gardening magazines and gives talks and courses at home and abroad. Charles, have we got you here now? Can you hear me? I'm concerned that his audio isn't plugged in. Nick, as my co-host, can you connect with Charles and make sure that he's connected and is able to hear us all? All right, I'll leave that in Nick's hands for just a minute. Let's continue with what we were talking about, materials for compost, because we've mentioned the main ingredients, your carbon and your nitrogen sources, but there's a lot of talk about other inoculants that can help to accelerate or increase the diversity of the bacteria or the fungal populations, things like essential microbes, EMs, biochar, rock dust, and so many others. Can you talk a little bit about your own experience and use of those in your own compost production?
Yeah. I don't use any of those things. I'm not really a fan of the EM. Really, if you're wanting to feed microorganisms in a compost pile, you could just use the same types of things that like I would use for a compost tea. So like kelp or fish hydrolysate, maybe a little tiny bit of unsulfured molasses, blackstrap molasses. So mix something up in a watering can and water it down. A lot of times what I do is I'll make a compost tea and I'll have extra compost tea, either full strength or diluted, and I'll dump that onto my compost pile. And I've noticed that it breaks down even faster over time. So you've got a lot of bacteria and fungi that are floating in the air that, you know, just by having your compost pile exposed to the air are going to bring in more microorganisms to help break things down. The best suggestion that I can give anybody, I don't know why I didn't think this right away because it's always my go-to for giving a suggestion, is to get a forest, what I call a forest soil inoculant. And this is one of the first things that Elaine taught me, that when weeded out at Rodale, go out to your nearest forest or woods. If it's a park, you're not supposed to be doing it necessarily, but if you can go out your back door or know someone that has a woods nearby, go and find some leaves and look underneath the leaves for some mycelium, which are going to be like white strands on the leaves or on the sticks or on the surface of the soil. This is going to be saprophytic fungi that is native and breaks down things and works in your environment. And take a couple handfuls from this area and then go somewhere else close by in the forest and look for some more, leaves with mycelium. I'll grab some leaves, I'll grab some sticks. All of these things that we're working with are microscopic. So a lot of this mycelium, you're not even going to see. What you're seeing is a buildup of the mycelium, that it's been there so much and overlapped that you're able to see it with your naked eye, but it's come up from the soil, from the forest floor. So by grabbing a little bit of this soil, grabbing some leaves, grabbing some sticks, you're creating an inoculant of native microorganisms, but especially native saprophytic fungi. And saprophytic fungi is what breaks down dead or decaying woody tissue. So by inoculating your compost pile or whatever it is with this, even a worm bin, you're helping to add microorganisms that are going to break down woody tissue especially, but work in your environment, and that's going to survive in your environment.
Nice. I'm going to quickly cut to Charles now. Can you hear us all right, Charles?
Yes, I can, Oliver. Sorry for being late.
No problem. I'm really glad that you're here. It's great for you to join us. And we were just talking right now about outside inoculants for compost. Now, I'm pretty familiar with your composting method. You've got great resources out there and videos on how you do it, as well as the materials that you gather. And Troy was just talking about the inoculants like saprophytic fungi from samples of soil from nearby forests that are already established. Do you use any other inoculants, things like perhaps biochar or rock dust, or really anything else that isn't normally the materials that you use as the bulk of your compost and seen good results with them?
Kind of. It's a question a little bit of how you measure results, I feel. And I find it very difficult in quite a general way to assess the effectiveness of many of the methods I use, because I'm doing quite a few different things always. I want my garden to flourish in the best possible way, so I'm never going to do just one thing. And I'm interested, you mentioned rock dust actually there, because I've never thought of it in terms of an inoculant, if you like, biological quality, but maybe it does, and I do add it. That's why I'm interested actually, because I feel it does bring something, but I would put it more in energy terms. This is where I go a bit off the scale, because it's nothing I could measure, but I feel there's a lot we can learn from energy gardening, like biodynamics and, well, I call it energy gardening. Schauberger, going back to some of Schauberger's early discoveries in Austria, where he found a farmer stirring water and singing. And his version of the biodynamics, which came later, this was in about 1910 that Schauberger found that. It preceded Steiner's work. But I think Steiner based his work on this kind of thing. But basically, this guy was energizing the water somehow with his sound. Who does that anymore? How much do we, or rather, how little do we know about that? I think there's huge frontiers here of stuff to discover, and currently it is quite topical to talk about the biology, which is fantastic because it wasn't for a long time. But I'm actually very interested in the energy, shall we say. I'm sorry if that sounds vague, by the way. It's stuff you can't measure, really.
No, not at all. And it is important as we continue to learn more about these frontiers of plant health and especially soil biology that only just a few years ago were either immeasurable or we had no idea what we were looking for. And I think being open-minded and creative about the influences on the health of the biology and the entire ecosystem in our growing environments is really important. So I'll throw another question at you. Since we've covered a lot about composting methods, different types, and what it is you're looking for, how to analyze its effectiveness with Troy already, can you tell me about, in terms of creating healthy compost for your garden, what are some of the troubleshooting things that you often work with your clients or other people that you consult with or teach that are very common mistakes that you see repeated over and over again that are easy to avoid? What are some of the things that you can give us some advice on to avoid those pitfalls?
Possibly the biggest one is moisture content, which is so hard again to describe because it's so variable. And from my experience, a lot of people get their compost too wet. And I actually went on a compost making course about 4 years ago now with an American guy. God, I can't remember his name, but it a bit that his advice was a bit oriented towards a drier climate than we have here in the UK. And he was talking about whenever you add something to your compost heap, add some water, which seemed appropriate to him based on his experience, I guess. And when I tried that, returned to my farm, it just got too soggy. And anyway, since then I've added the roof to my compost making area, and that's just made the world of difference. Getting the moisture level right, not too soggy. It's very rare in a temperate climate, I feel, that you need to add water. And that's partly because every green leaf you add contains moisture already, and that comes out in the composting process. So it's air. I think air is the most common thing that people struggle with, getting enough air in their compost heap. But then they've come to believe that two mistaken things. One is they believe, because they've been told that air somehow flows in through slatted sides. I think that's total nonsense. It doesn't. If you think about it, it doesn't really make sense. It means your heat is always going to cool down. It's going to dry out, blah, blah, blah. Solid sides are best. They contain the air and warmth that's already in there. You get the air level right by adding enough woody matter. And the woody matter is brilliant for bringing in the fungi that you've already been discussing. And that's the thing that's made a huge difference to me, is adding more wood. Since I bought a shredder in 2016, and we'd take green wood from the hedgerows, spare branches of elder and that kind of thing. And since doing that, I've noticed big increase of mushrooms growing in my beds, and sometimes when we're planting, or quite often actually, we find the soil has almost turned white in places. It's quite dramatic, but plants love it, and they're all growing really well. So putting more wood in is another thing. People are afraid of that, I think, a bit, but you just getting that balance right. The older I get, the more I realize that composting is an art as well as a science, and takes a lot of practice to get good at. But one other thing I noticed, and it's one of the reasons I was keen to join this evening, is how people's eyes light up when you get them near a compost heap, and it's a process that draws the imagination of many people. So it's something that it's great to talk about.
Awesome. I'm going to throw it back to Troy. Do you have anything to add to that of troubleshooting compost piles and figuring out the things that most people get wrong and are easy to avoid?
The number one thing that I run across with people is generally a lot of people are trying to compost food scraps. And like Charles mentioned, a lot of what he was talking about echoes what I was saying. But yeah, they're not getting enough brown material in there. They're adding too much green and not enough brown. So if you've got some type of food scrap composting that you're doing, or with a worm bin, especially if you're adding green material in, you want to add just as much brown material, if not twice as much brown material. So a 1-to-1 ratio or a 1-to-2 green to brown.
Can I add to that as well? The common misconceptions about, is this okay to speak? Sorry.
Yeah, please.
They've been told so much faulty information, like that you cannot compost, say, roots of perennial weeds. We compost all of them at the moment. We're composting huge amounts of bindweed roots, for example. We compost blighted leaves, late blight on tomato and potato. It's totally fine to put them in the compost. People have been made fearful, and they're not embracing the full joy of the process. I feel that you can pretty much compost anything.
Yeah, nice. That gives a little bit of inspiration there. And so before we move into the listener question portion, I want to ask one more question, which is, what is some of the advice that you would give for people who are just starting out? And we covered a lot of different types of materials and techniques for composting, but if you want to have success early on, which is often really key to encouraging people to dig further in and increase their knowledge and keep trying and experimenting, what would you recommend that they start by doing to get that early win and continue forward? Charles?
Okay. Yeah, start small and don't make too big a heap. You need to accept that you need a lot of material to fill a heap of any size. And so you're going to score results with a small heap, which will fill reasonably quickly. It may or may not get hot. That's a key understanding. Heat is not vital to make great compost. That would just happen more quickly if you get it hot. But you start small, and then that will get your hand in. And also, don't underestimate how much material you need to make good compost, because adding it more quickly with a decent amount will give you a faster and more interesting result. There's no doubt about that.
Troy, you want to give your answer to that question?
Sure, yeah. Did you see that Adrienne's on here now?
I did, yes.
Okay.
I'll go to her in just a second.
There's so many. I would encourage people to get into worm composting. Other than that, kind of like Charles mentioned a couple minutes ago, making sure that your moisture is correct. Really, so most people that I know that are really just getting into composting are usually doing something in their backyard where they're mowing their lawn and they're throwing that in a pile, and then raking up their leaves in the autumn and throwing that in a pile. So really just the two most basic things that work, and when especially, I'm talking about microorganisms, is air and water, just like Charles had mentioned. So we want to make sure that you're getting air in there sometime, by at least turning it once a month if it's just kind of a static pile, making sure that it's not getting too wet by having it just getting rained on, or too dry, like Charles mentioned, having a roof over the compost pile. It's great to have things, especially in the summertime or very hot climate. It's really good to keep things from getting dried out and to make sure and keep them moist. So yeah, just the two most essential things are air and moisture.
Troy, can I take you up on something there, which is, I don't agree actually that you need to turn it once a month. I mean, you kind of threw that one out a bit, but I would say that I wouldn't want to give anyone the impression that's obligatory, because it's something I come across a lot. They feel bad if they're not turning their heat. And I'm always trying to make people feel good about it. And, much as that might give a nice result, it's not obligatory. I'm sure you didn't mean that.
Yeah, I was just throwing a number out there. I meant, every so often you want to be adding air. I would say, like if you're checking on it and having a relationship with it, if you're smelling something funky, then you want to make sure and turn it. But yeah, Charles is totally correct. I was just throwing a number out there of once a month. That's not necessarily,
Yeah.
and that's absolutely correct. Like, I don't want to discourage anyone from feeling guilty about their compost pile.
Yeah, and they do though. It's, I don't know, they hate to feel they're doing something wrong. I find I have to be really careful what I say. I always try to keep it as simple as possible so they really grasp the simplicity of the process. And I find actually one turn is recommended, but I always say, you don't have to, because some people then they feel bad if they don't even manage one turn. But one turn I feel does give great value. And I like the phrase, do you know the phrase law of diminishing returns? Because I feel that applies anywhere. If you turn it more than once, you're not going to get a huge value from that in proportion to the very first turn that you make. For us, that makes a huge difference because it improves the quality and evenness and speeds up the final spreading actually as well. So we kind of get a return on time invested in the one turn. That's how I look at it.
Yeah, I completely agree. I'm glad that you mentioned that. But yeah, so generally when I'm making a compost pile, I may be making layers of, a couple inches of this and a couple inches of that. And you absolutely need at least one turn to incorporate all that material to get it touching up against each other. So you don't want all straw touching against each other. You want straw and leaves and manure and food scraps, so that that's kind of what activates that biology and gets it going, like Charles was mentioning, so for a more rapid breakdown.
Yeah, and if I may chime in on this one as well, it all depends on the temperature, right? Depending on how much heat you're generating. Sometimes, I've had students that make a 5-turn pile that turns out beautifully with tons of rich fungi and pockets and really beautiful texture, but it all depends on what those ingredients end up needing for the environment in which that pile is being created. So sometimes our goal is just to make sure that every part of the pile, in the curriculum that we teach at the Soil Food Web School, every part of the pile makes it into that hot middle for long enough to make sure that all the pathogens have been killed off, but in a way that enables oxygen to be there the entire time. So that's our goal. Keep the oxygen there while the heat's being processed.
Well, perfect. Thanks for jumping in, Adrienne. I'm so sorry we had a mishap with the scheduling, but I'm so glad you were able to make it in the end. Let me quickly just give your introduction so that people know who they're talking to when we open it up to our listener questions. So Adrienne discovered the Soil Food Web School after completing her PhD in chemical ecology. Upon hearing that it's possible to strengthen plant health and plant beneficial insect interactions while leaving all of the harmful asides, pesticides, fungicides, all of those aside, by restoring the soil food web, and Adrienne became dedicated to learning how to help her students make quality biocomplete compost and liquid amendments, and works with the soil food web now. And with that said, and although we're kind of running out of the interview portion, I would like to open it up now to listener questions. So if you would like to ask your own question, go ahead and raise your hand by going down to the bottom bar and clicking on the reactions and raising your hand. Jan, you've been patient enough. You had your hand raised earlier, so I'm calling on you first. Go ahead. Make sure to take yourself off mute.
Hello, everyone. Thank you, Oliver, for taking my question. My question was actually, if we get a material that don't get potentially pathogens in it, or seeds, like wheat seeds, what is the advantage of compost over putting the material directly on the field? So like woody, any kind of material.
Who would you like to answer you first?
I'm not sure I understood the question. What's the advantage of compost over undecomposed plant material? Was that it?
Yeah, maybe I can precise. So what is the advantage of composting the material versus putting the material directly on the soil or in the soil of your field? Like knowing that other people say that when you compost, you lose energy from your material, and you lose nutrients by volatilization or by leaching. And then if you bring the material directly in the field, the idea is that you get like a more dynamic soil food web, because it can break down, like you can use the total energy of your material as it has not been composted before. What do you think about it, and what is the advantage you see of composting versus directly bringing your raw material into the field?
Oh, can I answer this one? I think
Yeah, go ahead, Charles.
Take it away.
Yeah, it's the practicalities of it, Jan, as much as the theory. You know, I do see this written sometimes. You know, you get more benefit from putting it on direct, and it hasn't lost any carbon or whatever it is, oxygen, bacteria in the composting process. But having said that, as you know, in a market garden or even in a garden, you say food scraps, you know, if you put them on your beds rather than in the compost heap, you probably will get more rodents, for example. In our climate, you get more slugs when you put uncomposted material. And so it's actually a lot easier, quicker. And I think you do gain more by maintaining a compost heap, because compost heaps have their own microecology and are building bacteria and fungi and all sorts of things probably we don't even know about. And then they are returned to the soil in a more ready state, shall we say. I mean, like, I find it easier to sow carrots and plant very small lettuce seedlings in well composted material sitting on the surface rather than, say, lots of undecomposed material. I hope that answers your question.
Yeah, that's great, Charles. That's about what I was thinking as well. But also challenging the notion that you assume that there's something being lost in the composting process. And I know I came a little late to this party, but I want to shift our notion of compost from being organic matter that's either rotting and putrefied or decomposing, but compost as a vessel for microorganisms. So truly, if you are creating what I think of as compost, which is just, you know, surface area covered with all of the fungi, bacteria, protozoa, and nematodes that you need to really help your plants, then there's a big difference between compost and those undecomposed plant materials. because eventually those plant materials will decompose out in the field if you put them there. But if they don't get to do it with the full, complete suite of microorganisms, they're not going to do it as efficiently, or possibly with as much oxygen. So you might end up with some more toxic byproducts, or even lose some of those nutrients if it ends up going anaerobic. Or if you put too much nitrogen right next to your plant, you could burn your roots. So there's a lot of reasons to pre-compost your materials and then put it on the plants.
One thing that I've seen from growers around here, because I'm in a dry landscape in Spain, is that oftentimes plant matter will oxidize before it fully breaks down. And at that point, it's not really doing much other than essentially mulching and shading the ground at that point, right?
Yeah, I mean, protecting the soil is also a huge benefit. So even getting subpar compost without all of the microorganisms covering it is still helpful than compared to bare soil. So
it's an interesting question, though, and it's quite profound in a way, because, you know, it's like, hey, we're doing something that nature doesn't do here. You know, nature doesn't maintain compost piles. And I get that. I mean, you don't find vegetable gardens in forests either, it must be said. But I feel that, you know, we do have the ability to improve on nature using her natural processes. And that, for me, that's what a compost heap is. It's a wonderful organism of creation, actually. And we you know, we're not bypassing or cost cutting anything. We're just building something that's great and wonderful. And that's how I see the whole composting process. So, you know, going back to Jan's question and what you were saying, Oliver, too, and well, you, Adrienne, you know, we're adding through this process, and it's exciting.
right, we get to accelerate those natural processes in a way that makes more material than we could over longer stretches of time. And this is the benefit that we can do. And this is how we can engage with nature in a beneficial manner. So it's awesome. Let's get more compost out there.
Yeah, speeding up the process. That's a really good as well. Yeah.
Nice. All right, I'm going to go to another question. I've got Cameron Smith with his hand raised. Would you like to take yourself off mute and go ahead?
Yeah, thanks. I was just curious what your opinions are about application rates of compost and if it's possible to add too much.
Who would like to start with that one?
Looks like Charles wants to answer it first.
This is a question I get asked quite a bit. Well, particularly the second bit. Well, the first one as well, actually. Oxidation rates, if I understood that correctly, of compost, and that perhaps pertains to putting it on top. It just feels to me completely natural to put any organic matter, whatever it is, on the surface. That's always where it ends up in nature, apart from animals digging it in, but mostly it's on the surface. And that's how all the organisms in soil are geared to receive it, eat it, digest it, excrete it, and make it available as food for plant roots. And then, yeah, too much compost. Well, I'm sure it's possible. It's a question of, you know, it's a bit like how long is a piece of string? Well, what's too much? And a guy sent me a link on YouTube to a study by the University of Nebraska in 1870. And they were recommending 50 to 100 tons of well-rotted horse manure per acre per year for growing vegetables, market gardening. And nowadays that figure, I think, seems high. And how have we got to the point where that seems high? And I think it's for use of a lot of fertilizers, synthetic fertilizers. And I think people have forgotten really how much good organic matter you need to grow intensive vegetables. And that's what I'm talking about specifically. So when you say too much compost, it has to be clear what we're talking about. You know, if you're just, if you're growing fruit bushes, yeah, I don't think you need so much as if you're growing lettuce, carrots, and cucumbers, for example. So all those variables have to be taken into account, and getting the right amount, it depends on the state of your soil initially. Yes, you could put too much compost on, but it's much more difficult to do that than it is to put on too much synthetic fertilizer, say.
Can I ask a follow-up question?
Right. Yes.
When it comes to the role of calcium in plant nutrition and bringing up micronutrients in the plant, I'm curious. You know, I work mostly in degraded landscapes that are where they're you know, the landscape's been salted out by chemical fertilizers, and you know, restoring the, I mean, adding compost brings up cauliflower the size, you know, double the size of your head. But what I feel like I've observed is oftentimes when people are just recycling farm waste, they're kind of building up potassium in the compost pile. if there's nothing that's bringing calcium into it, then it could possibly result in a potassium imbalance. Now with like no dig, no till, I mean, there is the role of, our vascular mycorrhizal fungi, but I'm curious I'm curious what your perspective is on the role of calcium, both in soils and compost and micronutrients, the role of micronutrients as well, and then like how you think about that how you may or may not think about that when you're making compost, or if you're helping, say, other farmers make compost.
So I didn't mean to interrupt your follow-up question with sharing this graphic in front of the screen, but this can help answer both the first and the second. So here on the screen, this is what I consider the compost spectrum, where we have everything from putrefying organic matter that is actually toxic to plants, to which, might serve as some kind of nice starting material for a compost, but beyond that, I don't know. And then in between that, if we're lacking organisms, but it has nice, rich organic matter, like we talked about previously, this might be a really nice thing to lay down on your plants, but it's not, and protect the soil. It's not going to hurt. It's going to be organic matter, which feeds microorganisms. But if the microorganisms are not already in the soil, then it's not going to do much anyway. So we need to get those microorganisms back, and the best way to do it is to all of those particles of the compost are covered in the right organisms. So to answer the first part of your question, I would say confirm how much is in your soil to start with. So get your soil analyzed for the microbiology and see what your community looks like, because if you're missing fungi, that can change what kind of compost or who you want to put back into that soil. Whereas and that can also help answer your question of how much you need to add, because if you're working with dirt that's just purely mineral particles and bacteria, then you have a lot of work to do and you can add a lot. When you're talking about adding too much compost, any amount of this compost is too much, but you can never go too far on this kind of compost. So we've seen data where growing, starts in purely vermicompost that was just rich in organisms, like withstood cold snaps, heat waves, so many different environmental stressors. To your point about nutrients, a similar principle applies, where there's no one home in either of these composts who can balance those nutrients, because every microorganism is going to be in charge of their own nutritional balance of their bodies. So when you get the critters there, yes, those composts might be really rich in calcium or potassium or a certain element, but if you have a diverse suite of bacteria, a diverse suite of fungi, then the enzymes that they produce that'll deal with the excesses in a way that it keeps them locked up in their own bodies, so it's not going to be harmful to your plant, or dissolve in the water, which then, as the water dries out, could collect on that surface of the soil and create a hard surface level compaction layer. And instead, the microbes can take care of all of your pH issues and all of your nutrient balance issues.
Yeah.
Even if calcium is not in the system anywhere, like if it's literally like 200 pounds per acre for miles, and
yeah.
Okay. And so where does the calcium?
So,
I'm just curious. Where does the calcium come from in a situation like that?
So the answer that I would give is that there are certain soils that are lower in calcium content, like you're describing, right? So you may want to have some really eggshell-rich compost that you get into there, and think about it in that way, or even get eggshells, and that being somewhat of an inert material, and getting those out directly into the soil with the compost that you're adding, just as a little boost. But frankly, the calcium retention, once you have a fungal community, we've shown data that like 90+% of the calcium stays in the system because of the fungi, because they make these oxalate crystals that really just locks it in, so it doesn't rinse out of the system.
That's really interesting.
Can I add?
Please.
The role of calcium is something I've not ever thought about, to be perfectly honest, but I'm really interested to hear your observations, Cameron, on places where it may be really short. Clearly it's not here, and I think it's not for most people, but in those situations, I do feel you're describing a minority situation, shall we say, and clearly there needs to be a reaction to that. And I would recommend something like the rock dust that we mentioned earlier, because that or seaweed or anything of that nature, that's going to bring fantastic range of trace elements in a nice balance. And the microorganisms that Adrienne was describing, you know, in a compost heap, particularly if you go put it in the compost heap and go through that process, they will make it much more bioavailable to the plants that you subsequently grow. And that, again, that's the role of the compost heap. It can unlock so many things. And something like the rock dust I was describing, basalt rock, you know, it's in quite large particles often as well. Potentially it's really valuable if we can just get it more available to plants through the composting process. Brilliant.
Yeah, Charles, I haven't worked much with rock dust, but my understanding of it is that it is silica-based macronutrients. It's essentially adding more and different mineral components to that soil.
We actually have a bunch
So
of
then my
trials going on in
question-
India with rock dust right now. And I've been having it analyzed and the soils, and in places where it's short, the soils are short in calcium. And if people get rock dust from the same geology, oftentimes it'll just
The
bring
same geology
the same geology of that
as
place.
the source?
Yeah, as the
Okay.
parent material, like their parent material.
So essentially grinding,
Okay.
got it, grinding up those particles into smaller bits then.
Yeah,
Is that what it
and
sounds-
so I'll give you an example. One rock dust is high in copper, but the soil's already high in copper and is low in calcium. And so the rock dust is also low in calcium because that specific geology didn't have a lot of calcium in those rock formations. And so what you said is helpful because I've been trying to, the question, I guess the deeper question is, if calcium isn't there, is there a way for it to come into the system without bringing it from the outside? And the eggshells and bringing the calcium to the compost makes a lot of sense, and that's what we've been doing. And the only other thing that I'm aware of that may do it is arbuscular mycorrhizal fungi. If you have a connected system that goes on for like miles or hundreds of miles.
Why are you stipulating that it can't be brought in from outside? I don't see what's wrong with doing that.
Oh no, I didn't say. It's a question it's just an open question. I've been in debates where the claim is that everything can come from the inside, even if you're short on calcium, and the results that I've seen show the opposite. But I've also read that arbuscular mycorrhizal fungi can deliver all plant net nutrients across miles and miles and miles, but you have to have a connected system. And so I don't know what I don't know. So that's why I'm asking the question.
Well, fair
Right,
enough.
totally.
Yeah.
God, if it was me, I would get hold of some seaweed or something then. I mean, or, you know, there are definitely rock dust with higher calcium if you wanted that.
Well, Cameron, I also would jump in and ask, why are you concerned about the calcium? Are you noticing high compaction? Because I know that the calcium to magnesium ratio of a soil is going to lead to the way that those particles interact with one another. Is that the initial impetus for thinking about it?
Well, actually, the first thing that led to is this demonstration farm we set up was producing food, and I would taste the food every once in a while because taste and bricks kind of help with understanding the nutritional density, and the cucumbers started getting super bitter. So I ended up getting a soil test done, and the potassium and sodium were super high, and the calcium was super low. So we added 30-to-1 lime to gypsum ratio, and that fixed the problem really well. Like the food started tasting better, the nutritional density went up, and so I started getting curious about other places that we were working, and we started doing more tests. And there's places where there's high calcium or calcitic soils, but yeah, the ratios sometimes are really off. And there's some places, honestly, where the last 60 years of dumping urea, MOP, and DAP has just there's like white on the surface of the of the soil. So yeah, there's definitely compaction issues. I mean, the level of degradation is I've never seen it anywhere else, to be quite honest. But yeah, so but some people have claimed to me that you don't have to bring in calcium from the outside, and I'm like, well, explain to me where you get it from then, because ultimately these folks in these villages are eating that food. And I know high potassium causes heart inflammation, because when I was eating those cucumbers, I got heart inflammation, and I looked it up, and it ends up high potassium causes heart inflammation. I was like, oh, that's why I feel like crap. and I noticed that people's bodies on the farm, they're getting healthier than when they used synthetics, but they still weren't there. And so we made that switch, and we saw the change. And I mean, I saw the change in the flavor, and actually the change in people's bodies and energy levels. And this notion that you don't need to bring anything in from the outside. I've been challenging, getting a lot of pushback, and so I just and this is like the best panel of experts that I could have ever hoped to ask these questions to. So I was really interested to get your perspective on it because yeah, I just want it for the sake of the people eating that food. I just really want the truth to lead the guide instead of these kind of dogmatic notions that may be based on, an attachment to an ideal. But at the end of the day, it just comes down to like what people's bodies are going to look like and feel like after they eat that food.
You're absolutely
so
right.
thanks,
You need
yeah.
that bionutrient density in your food. And actually, I could imagine how you did see a benefit from adding that lime and gypsum to solve it briefly. However, keep in mind that lime and gypsum are both salts. I believe gypsum is also a sulfate, which is also toxic to fungi. So if you're adding compost and lime or gypsum, you're a little bit working against yourself. I understand that sometimes it has to be a transitional thing, but keep in mind,
lime is not a salt though.
So by salt, what I mean
Carbonate?
is that the carbonates will dissociate in water. They will dissolve in the water and then float away. And then when that soil dries out, it's contributing to that white layer on the surface and a compaction. So the calcium that you're adding in that is essentially making the problem worse because you're salting the soil and allowing the water to just smack right into it and have a hard compaction surface layer. So
Hey,
get the fungi in there. Yeah, carry on.
I have friends who I've worked with, but also just they're friends, so I keep a relationship with them. And the one of them is really into soils. They had a tract of land that it was suggested to them to lime, which in Tennessee, there's a lot of clay soil, and everybody from the extension office says that they need to lime their soils. So he did a little side-by-side test where he put down lime on part of his land and right next to it used compost. At the beginning of the season, tested it. Both were kind of low on calcium. At the end of the season, he tested the same soils. The soil that had the compost placed on it had healthy, acceptable levels of calcium and was higher than the side that he had put lime down on, which was just a little bit higher than when he initially tested at the beginning of the season. So the compost is actually what raised his calcium levels, plus gave him the microorganisms that are going to form soil structure and allow for better uptake. And then just to add on to what Charles was saying about rock dust, Dan Kittredge with the Bionutrient Food Association suggests going to like your nearest quarry and asking for rock dust, because the parent material for that is going to be most similar to what you've got in the bedrock of your soil. And by getting that dust through the interaction with microorganisms, you're going to make that available to your plants much quicker.
Thanks for that. I'm just curious. So the place where you put the compost down, that was not.
Hey, Cameron, can I interject for a second? We got to give a little bit of time for others to ask questions.
Sorry. Thanks for the time. I appreciate it.
Yeah, no worries. We have lots of other opportunities to get your questions answered in more details at climatefarmers.org. So if anybody wants to continue this conversation, we have many other opportunities. But let me throw quick to Liam, who's had his hand up patiently. Liam, would you like to ask your question?
Yeah, definitely. I have a significantly more basic question. So basically, I don't have the resources to, analyze the microbiology of certain compost piles. And from my understanding, a lot of composting just comes down to tips and tricks that might make it go faster, especially depending on certain ingredients and like certain environment that it's in. But I was just wondering, what do you think? Although it is kind of dependent on what you're doing at the moment. I have just a basic static pile that I work on with some people. I'm thinking of changing to like a windrow pile, but what do you think are the most important, I guess, tips to follow? Turning water content, checking for fungi like mycelium, which you can just see with your eyes. Like what do you guys think would be the most important to keep track of?
So we have a bunch of tips for folks to use as clues that might indicate something about the microbial community. I will also say that there are cheaper microscopes out there, so it's possible to get yourself a microscope, and that's the only way to truly know. So get a microscope, get a cheap one, but until then, We can also tell if you smell any kind of bad smell, if it's dark black, you probably have some anaerobic, possibly disease-causing organisms. If you have like beautiful dark chocolate, 70% cocoa brown, and also really rich earthy color, you probably have some better stuff, although the richness of that is harder to say. If you have mushrooms growing out of your fungus, or out of your compost, you may have some nutrients left in that pile that's undigested, because often, while it's great to see fungi and signs of fungi, if there's enough resources for that fungus to reproduce, that might indicate that they have plenty of undigested material left for them to take advantage of, or a lack of diversity, because in a healthy biocomplete compost that has all of the critters that we might need, you would have such a diversity that all of those fungi are even competing for the fungal-based foods. And there are certain foods, if you think about the sugar and the protein content of any of the foods, that's going to feed bacteria. And the more like structurally complex plant-based or woody dried out materials, those are going to feed more of the fungi. So that's my 2 cents for you.
Okay, Liam, can I say something? And I don't own a microscope. It would be interesting, I must say.
You should get one, Charles.
Yes, thank you. I've got a guy coming with one actually. He's going to do some checks. But
oh, great.
But the tool I'd recommend actually is a thermometer. And just because it's so simple and cheap, you can buy them like for £10 off Amazon. And I find that, you know, looking for that temperature range between 55, 70 centigrade, that's around, I think, 120 to 140 Fahrenheit, something like that. And the lower end of that range, you've got more fungi, and the higher end, you're going more bacterial. In a way, you don't need to know those proportions. You don't need to know the precise microbiology. But you know, like Adrienne is suggesting, you can tell a lot just by looking at the color of the compost as it's developing, the smell. So use your senses a lot. Don't be too overawed by what you might read and hear, because there are people out there who make it sound very complicated, and you've got to learn to, you know, just get on with it and do it what feels right to you. That simple thing of keeping it open aerated, but not necessarily with lots of turning. That's more about adding enough brown, chopping it into small pieces, and keeping that temperature range as far as you can within those parameters. And if it goes too high, add more brown, or possibly turn it. But mainly you should find you'll keep in that range if you get roughly half brown, half green, that kind of thing.
Yeah, and I'll also add that we have a general rule for a ratio that we tend to give about 10% high nitrogen, 30% green, and 60% woody, so that there's an extra little kick of a boost of microbial or bacterial activity in the beginning, just because every time they reproduce, it generates a tiny amount of heat. So that's where that heat's coming from.
Yeah, just to recap, so of course you need to use the thermometer to keep track of the thermophilic phase, but it really is just something you have to figure out with experience. Yeah, that makes sense. Definitely. Thank you, guys.
Hey, good.
Nice. Okay, guys, we're at the end of our time here. There is a lovely and engaging conversation going on that I hate to cut short, but I want to be respectful of everybody's time. And so I encourage you to go to climatefarmers.org to find all the other ways that you can engage with us. We've got a free academy there with a growing list of resources to help to answer these questions, as well as being able to reach out to us on the team. And before we go, I would love to give over to our panelists to tell how you can get in touch with their information and with them directly, so that you can continue to learn more through their sources. Charles, do you want to start off, and we'll go through the list?
Thank you, Oliver. Yeah, do head over to my website, where there's, under the Learn tab, there's a post on making compost with a distillation, 4 pages or so of my understandings, and a few links off that page as well, which will take you deeper if you want to go there. That's my advice.
Adrienne?
Yeah, I would be more than happy to talk with everyone. Again, I apologize for my confusion of the time, but it's so great to be here and hear all of your enthusiasm for compost. I have an email at photosynthesoil, which I'll put into the chat for everyone really quick. And I would be happy to answer more questions or engage in further conversations. It's just wonderful that more and more people are making compost, because we really can get the microorganisms in there to sequester carbon and get all of our healthy plants and feed a healthy human population.
Brilliant. Troy?
Hey, yeah, you can check out my website, which I'll also put in the chat, www.livingrootscompost.com, or troy@livingrootscompost.com. I'm most active on Instagram. I haven't put up a lot recently. I've just been super busy farming. I've also got my podcast, What's Brewing, a compost podcast, which you can find by searching for What's Brewing on Spotify or on iTunes. It's under the Farmland podcast series by Diego Footer. Diego helped me to put it out. And then there's also a good talk if you want to check out Diego Footer's In Search of Soil. There's a good talk on compost on there. Other than that, yeah, shoot me an email or find me on Instagram.
All right, fantastic. Well, just a reminder to everyone that this call has been recorded and will be released shortly on our YouTube channel at Climate Farmers on YouTube, and will come out on my podcast, Regenerative Skills. You can find it at regenerativeskills.com. And yeah, it was a little unfortunate that we got some of the timing wrong, but I'm really looking forward to having the rest of our speakers on some of the skill building exchanges that we have for our farmers network here in Europe, and perhaps on another panel in the future. I want to thank all of you again for your time today and for your insights and experience. I found this really valuable. I learned a lot, and I've been researching this for a while. So thank you once again. We'll look forward to reaching out and connecting with everyone again as soon as possible. Okay? Thank you all for coming. Have a great rest of your day, evening, wherever you might be, and we'll catch up with you again soon. Take care.
Thank you, Oliver.
Cheers. Bye. Lovely to meet you.
Bye, everyone.
Great to meet you, Charles and Troy. This was great.
Thanks.
Well.